So, yeah, I hope you can hear me properly. Yeah, I was told that actually somebody is going to introduce me, but I think we don't need to wait. There's a lot to cover, so I can assure you that we'll need the time. Yeah, first of all, I'm really happy to see so many people here for a quite serious topic. Some people say it's even boring. I would not agree, because it's something that I think is going to stay around. I don't really want to delve into, how bad the world is or how bad people are because they are not acting securely and so on. So I want to really intentionally keep all these moral things, these frightening, terrifying things out of this, but really stick to the facts and stick to the really, really cool technology behind it. So first of all, I introduce myself. My name is Stephan Kraft. I'm working for a company called Red Hat. And yes, I know how to ski, but I'm not a really good skier, and I'm not Stephan Kraft, who is this ski jumper. I've seen and tried quite a lot in my career, I would say. I was in the beginning indeed software developer. I was even studying at the university, at Technical University, some time ago, 5 years ago, 10 years, now I think it's 25, wow. Horrible. Yeah, then I was doing all kind of sales-related stuff, even going into management, different areas. I was even a university teacher, not here, but in the FH Technikum, program director. Then even trying something in Nicaragua with NGOs. Yeah, so my wife calls me weird, and maybe she's right. Yeah, now I'm business development. That's my official job title at Red Hat, around OpenShift. OpenShift is a Kubernetes distribution, you might know, and also application services, where actually this talk would relate to. I'm doing a lot in the community. I'm, for example, hosting the Keycloak meetup. We're doing a lot of user groups also around Kubernetes OpenShift. So if you're interested, just approach me, and I'm happy to share more about this. Yeah, and privately, I have 2 kids, young kids. They keep me awake at night, and I still love them. I mean, we all love our kids, right? Maybe less during the nights, but that's how it is. Okay, enough joking. First important question. Who thinks that security is important? Oh, yeah. It's just to wake you up, really, I know. But who thinks that security is actually fun and easy? Okay. Yeah, I agree. I agree there are stupid questions. In Austrian, we would say Ekloa. It's an obvious answer that I was asking or expecting. Actually, the topic behind is not so obvious and not so fun. I once heard a very good talk in YouTube by a security guy, and he also stated well, I think all of us, we're not stupid people. We don't do something intentionally that is insecure, but maybe we do it because it's just blocking us, or it's just maybe slowing us down. And I think everybody as a software developer or in other roles can agree to that sometimes we perceive security as something really blocking and slowing us down. So maybe if we, on the other side, want to introduce something that is more secure, instead of pressuring people, moralizing, let's try to view it as a security and experience problem, a user experience problem. So maybe we haven't done a well enough job to really make it as handy as possible. So, and there are good examples where this was successful. I think all of you know what SSL and TLS is about. Who knows when actually the early dates of TLS were? When did this start, when it was invented? Any ideas? 90s is already a good indication, yes. 95, yeah, it was Netscape, I think, pioneering in that one. So the technology is like 30 years old. So it's like web security has been solved from a technical point of view, but not really, or not as fast as maybe they wanted to. So if you look at these statistics about all the websites in the World Wide Net, and how many of them are really secured with HTTPS as we know it today. And you can see here really, I mean, this is only dates from 2014, so 20 years after actually TLS was invented, or the early, let's say, versions. Only 50% were using it, and then it was going up quite steadily, and now we're almost at, well, not really 100%, but very close to 100%. So any ideas why this acceleration happened? Pressure on one side, yes. Well, pressure always you need somehow. You need to know why you're doing it. Yes. Mobile development in what sense?
The internet going mobile, because at the beginning of 2010, the first real mobile platforms were invented. iOS and Android came to the market, so the internet was everywhere.
The gentleman said yes about mobile, and the internet became more, let's say, accessible, ubiquitous, and so on. But any other ideas? Actually, wanted. Yeah. Okay. Let's encrypt. Indeed. Yeah. That was actually the main point I wanted to make. I mean, all what you're saying were right. It was really let's encrypt. And if you look at these statistics, you see this is a kind of relating to that. That really the certificates that are issued per day was going up pretty much the same. Heavy pace from 2016, in fact. So what did Let's Encrypt really do very well? So first of all, it was free. Before Let's Encrypt, actually, it was quite expensive to get certificates and to rotate them and so on and so on. It was really designed very much for scaling and automation. So this ACME protocol, maybe you know about this one. So that really somebody who is just hosting a web page can very easily, in an almost automatic way, retrieve certificates and basically apply them to his or her page. And it was community-driven. So it was not really, let's say, an effort from a big commercial company, but it was in fact driven by the community. And all this somehow led to this really steady increase. So it seems that for web security, we have basically this mission accomplished. But Houston, we have another problem. Actually, we have lots of problems in IT still. And I'm now coming to this really kind of main topic for today, which is supply chain security. So if you look at these numbers, and again, I'm promising I'm not terrifying you. I don't want to terrify, but there are good talks out there that really kind of indicates how heavy this pressure is. And I mean, there are different, let's say, incentives or reasons why hackers are out there. Sometimes it's just individuals who, for maybe very idealistic reasons, doing hacking. But you have sometimes hacker groups that are really sponsored by state groups. We know from North Korea, the Lazarus group. We have from Russia. We have from other countries that are really sponsoring these groups to really convey the very specific reasons from a country, espionage, but also sometimes, for war crime and so on, or for war. And what more and more also is the case, and that's maybe the most recent trend, is that really hacking becomes kind of a business. So there's really a whole a business, let's say, network behind this. So really hackers specializing in the negotiation part, other hacking providing the support for the franchised hackers and so on. So this is really scary in a way that this becomes more professional, right? And of course, we as individuals, as organizations, as the IT industry as a whole need to prepare for that. So this is just what I mentioned before, the Lazarus Group, an interesting reading if you want from Sonatype, because they were just checking for this year, there were 234 packages uploaded from the Lazarus Group to different package registries like NPM or Maven Central and so on. And what they're doing is just basically cloning an existing, let's say, genuine and good, with good intentions project, And basically, it's very difficult to even get the difference. I mean, sometimes there's just adding some little typos or verbs or whatsoever. So for example, they have this in NPM, there's this Winston package. This is basically just for logging. And they just basically cloned this and called it Winston Compose, which makes some sense, right? And in fact, what this report shows, that just in, I think it was the first year of 2025, these kind of hacked, or sometimes it's called repo-checked repositories, were downloaded 36,000 times. And of course, I mean, when they do this, they usually add some malware, some backdoor, whatsoever. So you can for sure say that 36,000 times it was downloaded, is now installed, or at least present, and on some developer machines. So this is scary. And the question is, again, what can we do? The basic question behind this is, in fact, how can we easily distinguish the good guys and the bad guys? Or let's put it maybe different, the guys with the good intentions and with the bad intentions, because still good guys can write bad code, we know this. But at least if we trust somebody, then we are more secure that this person has not added any backdoors or whatsoever. So this is actually the key question that we should answer. Any ideas how technology could help there? Please.
Blame.
Sorry?
Git blame.
You yes, to make it more transparent indeed, yeah. But even maybe more technical. I mean, you can technically blame somebody as well, but some more technical. How can you prove identity, in fact? Certificates, right? I mean, this is also not something that is really new. So cryptography in general, private public keys, we know all this. We're using this for web security, right? And in fact, what cryptography can do in this context is really two things. First, it can prove that something is really coming from a certain person, identity, so provenance, it's sometimes called. And the other thing is the integrity. So if something is signed and later on somebody who would change it, you would immediately see, okay, the signature doesn't map anymore. So you can basically prove that this, during the event of signing, that this content is the same as you have it now if you download it. So this is great. The problem on the other side with private public keys is it's difficult. It's not really convenient. It's not really good user experience. So, for example, it's very difficult, not impossible, but difficult to really bind an identity to a private public key, because just because something has been signed doesn't say that it has been really signed by this person, by another person. So, of course, I mean, you can maybe upload a page or saying, okay, this particular person has this public key. That's how sometimes it's done on open source repos. But still, it's a somehow weak link. It can be also basically changed, and somebody needs to look it up and really implement it. The second thing is, of course, how do you distribute the public keys? Yeah, this is something, again, if you're talking about in your company, then this is doable. But if you're talking about really downloading something from the internet, how do you really get the public key from the person? Not that trivial. And then, of course, how to revoke public keys? Because we all know keys can get, let's say, leaked or can tampered, whatever. Then you, of course, need to inform basically your consumers that this public key is not trustable anymore, and please now use another one. And yes, by the way, we should automatically rotate keys and certificates. It still sometimes happens that keys are staying out there without any time bound, any limits whatsoever. And of course, if a hacker gets in control of such a key, then basically this is very bad. So ideally, they should be rotated maybe once a year, 90 days whatsoever. And of course, again, this doesn't make the whole management easier. So it seems somehow we have a user experience here. Technology is there, but it's not really used properly, or it's not easy to use it. So just for me, interesting, who has ever signed already a container image? Yes, okay, we have 1-2 persons, great. Who has verified the signature of a container image so far that he has or she has downloaded? Okay. Again, 3, 4, 5. Good. My real hope that after this talk, everybody will raise their arms and say, it's that easy and convenient, and I cannot live anymore without signing and verification. So, is it sufficient to just tell you, please do it? Just, make another, I don't know, course, and there you will get taught how everything works? Most probably not. So, and that's exactly where Sigstore comes into play. Who has heard about Sigstore already? Okay, again, a few arms. Great. So you will hopefully get to know it today. So Sigstore, first of all, where it's coming from, it's an open source project backed by the Open Source Security Foundation, OpenSSF, which is under the Linux Foundation. So there's some blessing to this project. It's not coming from somewhere. It's really quite wide support, as you can see. There's Google behind, JaneGuard, Red Hat, Purdue University in New York, and many, many more. That's maybe the most, let's say, busy or contributors to this project. And the goal is very easy. It's about simplifying signing and verification of any kind of software artifacts. And we will say later on what kind of software artifacts this can be. It's not only a specification, because specification paper is very patient. You can write whatever on papers, but nobody's really paying attention. The good thing is with Sigstore, at least from the backend side, there's also a so-called public good non-profit service. So in fact, you just need a client utility, in fact, and then you can talk with this backend if you want. And this is in fact just a service that is provided, I think, by Purdue University. Red Hat and Google is also helping there. So it's maintaining this infrastructure that you can use it. And there's some very good, coming back to the user experience, very good CLI-based tooling. It's mainly called cosign and gitsign that can easily be used on your laptop, integrated into a CI/CD process and so on. Who has ever stumbled about cosign or gitsign? Maybe this is more known. Okay, a bit the same. So this, in fact, is the tooling. Everything is under the Sigstore umbrella. So what is Sigstore exactly about? A very good description is, it's a bit like the Let's Encrypt for supply chain security. This is not coming from me. I've seen it somewhere, but I think it's a very good, let's say, laser focus description what Sigstore aims to achieve. Because we're talking about Let's Encrypt, let's make this kind of comparison. So first of all, both of them are free. That's already good. Both of them are community-driven. And both are designed for high automation. Yeah? So in fact, getting certificates or getting something for signing, verification, everything can be done in an automated way. And both of them are a CA, a certificate authority. So Let's Encrypt is about certificates. Full CTN is also about issuing certificates. Of course, the domain, or let's say the scope is different. Let's Encrypt is for TLS web server authentication. Fulcio and Sigstore, I will explain in a second what Fulcio is about. Sigstore is about software artifact signing. Also, the subjects are different. For Let's Encrypt, it's about DNS domains. So usually if you have any kind of web server whatsoever. And for Sigstore, the subjects are people or workload identities. Yeah? So this is in fact the kind of the receiver of a certificate. The question is always, okay, how do you ensure that the right persons or the right servers or the right workload identities are really getting the certificates? Well, for Let's Encrypt, we have this ACME protocol, which is in fact just you have to prove against Let's Encrypt that you're in control of a DNS domain by putting something there and so on and so on. Any idea how you could validate people or workload identities? Anything that is already out there? To not reinvent the wheel, but use something that is already quite present in many companies. Say it again. keys is already the result of the validation, but I'm really talking about the validation. In fact, I'll give you another hint, authentication. How do you usually do authentication? Say it again? Well, it's the place where you put this, but what's the protocol for doing all this authentication? Yeah, I heard several things. So there are some true things as well. OAuth is in fact the basis, and OpenID Connect. Okay, who has heard about OpenID Connect? Yeah, there are many. It's in fact was mainly used for this SSO, for single sign-on, but in fact it's just a protocol to ensure that somebody is authenticated. Yeah, and it's mainly used for people. And this is in fact what Sigstore is using as well. So now I'm getting many, many different things together. How does this really work? And also relate to what I said in the beginning. So what are the main protagonists in this kind of Sigstore environment and ecosystem? So the first thing is the OIDC provider. Yeah, this could be a key clock. This could be something in the cloud. This could be an Okta, there are different providers. And this OIDC provider is in fact, and this is something actually outside of Sigstore, and basically you can kind of view it as somebody like if you go to a, I don't know, a ministry or, well, usually a ministry, but you want a passport and so on. There's usually some nice officer, and you have to prove towards this officer that you are who you claim to be. In the technical world, this is actually done usually with username, password, or things like multi-factor authentication, that you have to prove your fingerprint, your passphrases, whatsoever. In fact, what is important is at the end of this process, you get a JWT token, a JSON Web Token. This is basically proving that this OIDC provider has done the authentication, the validation, and the receiver of this JWT token is who she or he claims to be. Yeah? So this is in fact the first step. The second step is Sigstore Fulcio, and now I'm explaining what Fulcio is about. Fulcio is in fact a sub-project, if you want, from Sigstore, and this is the certificate authority. And this certificate authority basically gets, as an input, a JWT token and a public key. Plus, the person or the sender to the Sigstore interface has to also prove that in fact he or she is in possession of this private key. He or she can do this by just signing, in fact, a JWT token with the private key, and then Fulcio can validate that yes, this public key indeed corresponds to this private key. And out of this process, in fact, Fulcio issues a so-called X509 certificate. The same object, the same structure that we use for TLS, but in that case, the subject, and we will see it later on in the demo as well, is in fact then this person that has been authenticated via the OIDC provider. And the third component is in fact just a ledger. You can think of it a bit like a blockchain. And in fact, this blockchain just documents all signing events. So whenever something is signed, then this is also, it has a new entry which is associated with this certificate. And this allows that if you have a certificate that has been issued by Fulcio, that in 1 week, in 1 month, 2 years later, you can still validate that this certificate was valid during that signing event. Why is this important? Because the great thing about Sigstore is we're using so-called ephemeral certificates. So they are usually only valid for one signing event, and really only valid for usually 10 minutes. So you can think of it, usually everybody of us has a passport or a personal ID or whatsoever, but you can think of it, it's always cumbersome, this passport, you can lose it, you have to carry it with you and so on. In fact, if you just take this analogy, you can imagine you're just basically having this, this process, and whenever you want to go to another country, you get just basically a temporary passport just to enter to this country. somebody can validate that really you are the right person to do this and to enter this country. And then basically this passport will be thrown away. It's only valid for 10 minutes. And that's great because it just increases and improves the security big time. So if you take all these three together, you get exactly this kind of statement that indeed one software artifact has been signed by a specific OpenID Connect identity at a certain time. Together with the ODC provider, Fulcio and Raycore, you can basically confirm this. There was a question, please.
How does Sigstore ensure there are no malicious OIDC providers? Because I could set up an OIDC provider to claim I am a Google employee.
Yeah, good question. I just repeated. So how does Sigstore ensures that there are no malicious OIDC providers? Well, in fact, you can configure Fulcio to trust only specific OIDC provider. Yeah? So this is in fact part of the configuration of Fulcio. So you would say, I only trust GitHub, I only trust, for example, Google, I only trust whatever. And then only JOT tokens from these OIDC providers would be accepted. If a hacker would kind of come with his own OIDC provider, Fulcio would say, sorry, I don't know you, I don't trust you, okay? We'll see it later in the demo as well. So, bear with me. I know that this slide is an awful lot, yeah? But hopefully in the demo, things will get clearer. So what are the key advantages of Sigstore against other solutions? The first thing is the signing can really be done with short-lived certificates. Sometimes you even call it keyless, which is wrong, because keyless, there's always a key associated. But it's really only issued for this specific signing event, and afterwards it's not thrown away. That's actually also wrong. But it's basically not anymore valid, because the validity, and we'll see it later on, is only for 10 minutes. The good thing is the private key, which is the most crucial and confidential thing, will never hit the disk. So it will just be generated. We will generate the key pair, but it's completely hidden to the end user. And in fact, it will only be used once for signing and then will be thrown away. So the private key really doesn't hit any disk, so which is a great improvement for security. The third thing, the verification is done against identity. So we'll see it later on. If we do the verification, we will not say, just a second, we will not say, okay, I want to check it against the public key, but we will say, I want to verify against a specific identity. So an email address and OIDC provider. Please.
Does this mean for every request a new private key is generated?
That's correct.
So this would be prime numbers and a lot of computational effort to generate this key pair.
I'm not very much into these algorithms, but yes, there's an overhead. But that's what happens. Yes.
Very cheap, usually.
Yes. I agree, but that's what happens all the time, and we see it if you do 3 times a.
The key pair and the private key is kept private, and
the private key
is the public key.
The public key is included in the certificate indeed, and the private key is thrown away. The private key is thrown away. So
it's just produced.
It's just
generate the certificate.
Exactly. We'll see it later on in the demo, but that's what it happens. Yeah, indeed. The good thing, coming back to user experience, the signing and verification can be really done in one command, which is great. So I don't need to, as a developer, first generate a key pair and then put it somewhere in a directory and then reuse it and then so everything basically is, I'm just saying cosign sign, and that's it. We'll see it later on. The good thing is this Raycore transparency log. In fact, if you use the public good instance, it's really public. That means everybody can see it, which has, of course, let's say good sides and bad sides. I mean, if you put some data there, everybody can see it. On the other hand, everybody can also monitor it. So if something is happening, if maybe some malicious person is trying to use it several times, then there are monitors out there that hopefully would detect this. So half an hour is gone, but now I hope you are really curious to see the demo. And hopefully then things will get much clearer. So this is the demo flow. We'll have 2 sections, in fact. I mentioned that with Sigstore you can, in fact, sign everything. So digital, of course. I will just give 2 examples because I think it's the most applicable things here to this audience. The first thing is container images. And the second thing, that you can also sign Git commits. Because at the end, if you do a Git commit, it's also an object with a payload, and you can sign it and also verify it. So this is what we're going to do. And now cross fingers that everything works. So just checking the internet. My mother was calling me. That's so typical. I mean, if there are 3 calls in a row, it's always my mother. I can already bet on that. Anyway, so we are here in the terminal, and in fact, what I've just done to prepare this demo is I've just uploaded to Quay. It's just one of the container registries that you can use, but of course, the same would work for Docker Hub or anything else. Just an image or repository. It's called any image, and we have 2 tags that we can play around. Yeah. At the moment, it's really completely unimportant what's contained in these images and so on. The only thing, they are not signed yet. That's the only important thing. So let's go here on the command line. I've just set this environment variable, which is exactly pointing to this container registry. And now, in fact, what I can do, and really, I promise I haven't set any hidden environment variables and so on. There's no key out there. So it's really, in fact, a blank laptop. The only thing what you need to basically reproduce this demo, you just need to download the utility cosign. That's it. Yeah, this is installed on my machine. And now what I can say is just sign this image, and I'm just adding a tag. It was 10. And let's see what happens. Do you think that will work or not? Okay, I get a thumbs up. Okay, why not just try it? So the first thing is just because a cosign is using Sigstore, he's just giving me for information and so on. And he's just saying, okay, are you sure to continue? I'm always sure. I mean, come on, I know what I'm doing. And what is happening now, and that's the interesting part, I haven't so far authenticated with anything. So he's basically rerouting me. Yeah? And I'm opening now this browser page. And this is just by default Sigstore, this public good instance that we're using as kind of the backend, is offering 3 different options to authenticate. Okay, I think the gentleman over there asked about the ODC. If you bring it, this is in fact just that Fulzio decides, and I'm using Fulzio in the background. I'm only trusting these OpenID Connect providers. If you would host your own Sigstore instance in your organizations, on your infrastructure, then it's up to you to decide which ones you trust. If you're using the public good, that's the only thing you can trust. Or that you can use, sorry. So because I'm using GitHub, I'm just clicking on this one. And what's happening now, going back to this page, he's just again asking me something because it's actually a private registry. And what has happened now, that he's created a signature for this image. And also he's telling me, I've created for you a transparency log entry with index this one. So you remember on the right side, there was this transparency log. It was in the Sigstore, it's called Recore, but doesn't matter. And let's now copy paste this one. And in fact, if you want to follow, you can even do this on your mobile as well. And I'm just using here, this is just a nice, let's say, web page where you can query this transparency log. Yeah? I see already some typing. Please do so. So you just need to enter search.sigstore.dev. And then you get this kind of user interface. And I'm just now copying exactly this log index to this query. And this is exactly what has been included in the transparency log just of this signing event. So first of all, you see that this really happened just a minute ago. I was not faking it. This is the log index. And this is now the public key certificate. Just some things to mention. First of all, as I said, the certificate is only valid for 10 minutes. Was created 1 minute ago, is only valid 9 more minutes. Okay, altogether 10 minutes. This is the algorithm that has been used. I was not asked, actually. I mean, Sigstore is just using this by default. This is actually what is putting in the certificate. It has to be used for digital signature. And if I'm going down here, this is my email address. That's how I'm registered with GitHub. And this is the OpenID Connect issuer. Okay? So this is a valid certificate, and this certificate has been used, or let's say the private key that is belonging to this certificate has been used to sign my image. So if I would now go back to Quay, I would see if I do a reload, in fact, hopefully, if everything has worked, a little icon here that this container image has been signed. Okay? So Quay is a bit smart in that context, because the question is where do you think the image of this, the signature of this container image is actually located? No? As well, in the record, indeed. Yeah, true. For container images, actually, it's very difficult to guess. For container images, he's doing something very smart. He's just adding, in fact, an additional image tag, which is not visible here. So Quay already knows, there's another image tag pertaining to this 10. So he adds this icon. But in fact, technically, now we would have 3 different tags. So this 10, 20, and then a third tag, which is in fact the signature, or the container image with the signature of this version, which is just nice because we don't need to put the signature to separate location for verification later on, but we just query the Quay. So the big question is, where actually is the key? Any ideas? Yeah?
It was generated on your laptop and it's described.
Exactly. It was just generated during this comment. Yeah. So in fact, if I go here on the presentation again, this is what happened during this signing. So actually, I'm the developer. In that case, I'm the role. Yeah. So I say, I want a certificate. In fact, I say I just want to sign an image. I don't even say request certificate. I say I just want to sign something. So what first happens, that he's checking whether there's already an existing session with the OpenID Connect. If yes, then he's getting the JOT token. Then actually the Fulcio certificate authority is contacted. Fulcio then verifies that in fact the JOT token and the public key kind of work together, and then publishes this information to the record transparency log. And if everything works and also record kind of confirms back that yes, I've included this, then in fact he would provide back to the developer this signing certificate, and then in fact he would just sign this artifact. Everything here has just happened in one comment. So I didn't do anything else before or after. Everything, this whole flow was really done in this one comment. So, going back to the demo, of course, signing is nice, but we want to also verify. And this again works with the same comment. In that case, we just say verify image. What do you think will happen now? Okay, it should work, but actually this time it will not work. This is always to just increase the suspension, because you're saying, okay, I can check whether there's a signature, yes, but against which identity you want to verify this. So in fact, for the verification, I also need to provide now the identity, which is in fact Certificate. Danke. So, does this work now? No, because he also wants the OIDC is here. It's always a pair, in fact. Yeah? So I need to also provide the identity Now, where this is here, and this is in our case. Let's go back to Recore. And just to have the output a bit nicely formatted, let's do a JQ. So what he's doing, in fact, now he's checking in Recore that everything is available, that all the claims are correct, that in fact I'm really the person who has signed it. So it's really checked that actually it's checking against the issuer, the subject, and this is in fact just this big body that's just encoded the Recore entry that we have seen in the search portal before. So that's it. That's about verification. The question is, of course, how you can do this, because you usually don't want to have this comment. You can even do, and I show this, who is using Podman? Yeah, okay. You can even include this verification in Podman. So if you have, and I've just prepared this, if you have a policy file, so you can basically redefine either per registry or per repository or whatever, what you're actually expecting in terms of the signature. So in fact, what I've done with this cosign verify is in fact codified here. And that means automatically, whenever I do a pull or I do a run, then in fact these policies would be applied. So if an image would not be signed, and we can even try this out, because I have now, if you remember back, I have these two versions. So 1.0 is signed, 2.0 is not signed. And let's maybe do just check and say pull image from version 2.0. And now we'll try to pull this. And of course, rightly, the error message will be that there exists no signature, and that's the reason why he would not do this. The same, there's also a possibility, of course, if you're running Kubernetes, there's some Kubernetes native features that also would do, in fact, the same thing, that they would just check against a certain signature. Okay, any questions? We have a bit more time. I will do the same thing for Git commit signing, but any questions about this flow? Yeah.
How would I set this up in a CI server? How would the CI server authenticate against GitHub, for example?
Well, how the CI service is authenticating against GitHub? You mean during this flow? Yeah. What I'm showing. Okay. Well, again, first of all, you need to have your CI/CD provider trust in the GitHub, because otherwise it would not work. So you need to have this exchange, in fact, configured upfront. Yeah. Because otherwise, exactly this flow that we have seen before, where when you do the signing, then you get to this page and say how you want to authenticate, and you have certain providers. And of course, in a CI/CD, you would not have this flow here visually, but it would happen implicitly. Does it make sense?
GitHub, are there like accounts for organizations which I could use here?
Well, GitHub already provides some good integration with Sigstore. So there's, I think, a GitHub runner action available that, in fact, is connecting to Sigstore and so on. So what you always can do is using the CLI tools. But I think in GitHub, you have quite a good integration already out of the box. Okay. There was another question, I think, over there. Please.
But in the enterprise environment, it's a CI/CD pipeline.
Yeah.
If I assume you have your own IDP, and you want to sign an image that was created in the pipeline, you would need to register, or you would need to authenticate by the IDP.
Yeah.
I would suppose you will need a private certificate of the machine, and then you would get the same problem with authentication and so on.
Partially correct. I mean, yes, you can also, in fact, even with cosign, you can bring your own certificates or bring your own keys. That would work as well. If you don't want this keyless. If you want to still use keyless in your own organization with your own IDP, then you need to set up your own Sigstore instance.
Yeah, exactly. But the authentication by the IDP,
Yeah.
you need some credentials, and usually it's like in CI/CD pipelines you need.
Yeah, that's the same thing. Yeah, how you authenticate to the OpenID Connect provider is in fact out of the scope of this. Yeah.
Yeah, sure, but you will need anyway some of the authentication
Yes.
information.
That's correct, yeah, that's correct.
Okay, doesn't solve all the problems.
Doesn't solve all the problems, indeed. I mean, how you authenticate, that's really up to you. I mean, there are cool solutions. A completely other talk that I love as well is about this Spiffy Spire, because it allows authentication towards this server without having these keys. But it's another product, another tool, another talk. Yeah. But you're right. In fact, Sigstore always assumes that you have some kind of relationship with the OpenID Connect provider, and you solve the authentication somehow. Yeah. Yeah. Okay. We're only 10 minutes, so I have to rush a bit. I would like to actually show you also now the demo for Git signing, because I think that's maybe even more relevant for you. So we are here in a Git repo. Yeah. So I just basically set up a Git repo. You can see it's here. It has already some directories, but doesn't matter. And I want to also show how this works. In fact, if you want to sign a Git commit. So let's just create a file. Let's call it DevFest, that we can recognize it later on. And now what I want to do is, in fact, show you different ways of signing. Just that we see that nothing is yet there. I show you the Git config. So in fact, it's just a standard, more or less empty Git config. Yeah? Nothing relates to signing at all. So if I would now, for example, I'm just adding something to this file, then do a git commit, say blank commit, and yeah, let's do this. So I'm just doing this, and now Git kind of tells me, well, you didn't even declare yourself, your name, and so on. So this is not ideal. So what I can do is, and I've just created a little script here, is just I'm setting my credentials. So in fact, now I've just added to this Git config file my name and my email address. Yeah? Let's do the same thing again. So I'm just adding something and then committing it, and let's call it now commit with self-declared creds. So actually not really something particular, has just changed the kind of warning, or the info message is going away. And if we look at the actual payload of the Git commit, in fact, it's just containing some hashes, and then of course my password and so on. So let's play around with that. I mean, I think you as kind of seasoned, experienced developers will not really surprise, but let's maybe just fake this. Yeah. So in fact, of just putting my name, my email address, let's use the ones from Mr. Linus Torvald. Yeah. So I'm just adding this to his email address and so on. And do the same thing again. And guess what? If you look now at the payload, then now I have a nicely commit to my great Git repo from Linus Torvald. Yeah? So even if you look, I can just push it as well, that we see it also in the Git repo. Because I'm really proud of that, of course. I mean that Monsieur Linus Torvald even committed to my repo. So in fact, this is funny, but of course this happens. And if you are familiar with that, I mean, you can easily be faked right there. So and that's exactly where signing again also with git commit comes into play. So let's do this. I have again a little script. And this is just adding some settings in my config file. Again, if you want to try it out, you only need to download, in that case, git sign. Yeah, you remember cosign, and this is git sign. And then add these little things to your git config. So in fact, what I've added here is, this is my name, okay? And just adding that, from now I want to sign everything. Don't get confused that is saying GPG sign, it's not. That's just for legacy reasons. In fact, we're using the signing from cosign or from git sign, but it still is kind of the environment or the property is called gpsign. Then we're just saying, okay, for signing, we want to use actually a tool called git sign. Yeah? So it's program git sign. So whenever we do the git commit now, it will just basically kind of pipe out or refer to this git signing tool. And then we're just specifying the format, which is X509. Nothing else. So if I do now, again, the same thing like before, again, do a hello and now say signed commit. Actually, the same thing will happen like with the cosign before. He will go back to this browser, will offer me these different options. I will say, okay, GitHub again. And then, in fact, everything continues. The Git is signed, and again, the information will be uploaded to this transparency log. And of course, I can do the same thing with git sign verify. And he would again ask me for identities and so on. Yeah? The same thing, actually, I've done the verification with cosign and the image. I'm doing it now for the git sign. I can do it for the latest git. I can use it for any git that I've done even like years ago, because the entry still in the record exists. Yeah? And that's the great thing. Even if the certificate is long time not valid anymore, but still the entry in the record exists. And that's it actually with the demo. Let me just quickly wrap it up, and then hopefully we'll have some time for some more questions. So this I was showing, in fact, what's happening behind the scenes. This is just about the flows themselves, but I'm skipping this for time's sake. How does Reddit comes into play? We are offering the possibility for a private Sigstore. So the question was about if you want to use your own IDP, if you don't want to publish, let's say, all the information to this public record, you can run your own private Sigstore, and Reddit is kind of providing a distribution for that, which is called Trusted Artifact Signer. So just to recap, supply chain threats are on the rise. Signing is just key, and signing and verification is just key to really have this provenance that really ensure that you don't get something that is basically coming from a bad actor. Conventional signing is just cumbersome and risky. You need to basically, for example, if you want all your developers to sign their Gits, you need to basically roll out the private keys, then you do the verification. You need to ensure that really you do it with the right public keys. You have to rotate them and so on, which is just a pain. Yeah? And Sigstore is, in fact, come to help you. It's an open source project. It's free. You can just use it. It's a bit like the Let's Encrypt, as you said, and hopefully makes the whole process just easier and more secure. If you want to use your own IDP, OpenID Connect provider, or you don't want to put this information into the public transparency log, you need to either just download the Sigstore and host it on your own, or you refer to a provider like Red Hat with the tool Reddit Trusted Artifact Signer. That's it.